Hey everyone, welcome to my video. Today in this video together we will be modeling this smart sheet metal joint example. Let's close it and then open a new part and then continue. First we create a new part and then on top plane I do create a sketch. I select a plane and create sketch. Then I go to my sketch. I pick from here a line, a rectangle. Dimension is 90 by 65. Good one. And we can go from here to fillet, sketch fillet, radius is 5, select everything, and program going to put for you a nice fillet. Once you are done with that, you go to sheet metal and base tab. I'm creating here a 3mm thick plate. We say this is good. We can later on save this part here. Plate 1, let's say. And then we create a second part. On top plane, again I create a sketch, and then I will create here a rectangle. How to do that? Just I drop here a rectangle, select my edge, I click my control, select the origin, and I say coincident. So in the center, here we do have 55, here we do have a 90mm. Once you are done with that, you close your sketch and you go to base flange tab. Is this the good that our sheet metal inside of our profile? I'm going to open direction, changing direction, height is 30. Okay, this is good. And I will create here corner rounding. It is appreciated to have a corners radius on the corners always at the sheet metal, because somebody can hurt your technician when they are building. They can hurt themselves. That is a good habit to create always this. I created here a sketch as well. I'm going to create here one more feature, which is a 35 by height 15, so half will be 7.5. I cut my part. Again, a fillet. We said that fillet always appreciated. It is good. It reduces the danger of. Yes, guys, this is also good. And plate, this is not plate, let's say bracket 2. We save them. So at the background, if you look here, we know we have 2. You can tile horizontally, vertically, and you can come here and say, no, I don't want to use them, and when you want to cascade them. That's good. So we go to assembly now. We create a new assembly. We invite those 2 guys and we select them, and they will be placed in our assembly environment. So they are randomly placed. Bracket is fixed because you understand they're fixed. I'm saying float. We are going to remove them. I select front. I open this 2 object. In fact, first plate, front and front selected. I go to mate. Front and front selected. Top and top selected. Right and right selected. So I fixed my first object. This is plate. Now we are going to do for the second. Mate again. Select the surface. Select the surface. That's good. Select on the bracket your right plane and come in the SE and give that coincidence here as well. It is always good to work very structurally, guys. Otherwise, your life will be very difficult with this program when you are working. These are 20 years experience. Please listen me. So first we are going to give here a 5mm length. What I see here, I made a wrong operation. First I'm going to save as SC. I say SC. I need to update something. I click my part. I say add part, bracket active, base flange. This was 80. Select OK. It will be updated. Close. We save again. Why I brought this two part here? It is always good to work with your components in the same environment because you will see they have connection with each other. It will make your life easier. Believe me, this is the way how we work. Otherwise, you're gonna spend a lot of time. Say edit part on the back plate, simple plate. In fact, this is our sketch. We are going to create here a sketch, and first I connect these 2 points. Then later I will create here one extra line, and then I will give a dimension of 10. No, 15, sorry. I select this one, I created a rectangle. I select the center, I created here a center rectangle again. Those two is selected, we make them equal. I give here dimension of 10. So right click, select chain, everything selected. We select here mirror, mirror have all our entities and mirror about. That's good. We created it. And then I will say my program now, cut for me this plate. Link to thickness is good. It is cutted. These are our joints. Now I need to make same operation. It will be now the addition instead of cut. I select my part and I activate it. Simply to be able to activate it, we say edit part. That part will be edited. That's the working part. So bracket is activated. On top plane I create a sketch. What I need now from plate, that's sketches. Here I select them and I convert them. We close our sketch and we create extrude both space, merge result active, link to thickness will not be there. I will make this 2.5. I don't want them to protrude from my surface. That's the idea. And we close it and let's see what we have now. It's nice. Let's make it much more detailed. We select edit part. We look from top and we are going to add here holes which will help us to remove our sharp edges, because as you see we didn't create any tolerance. If you keep your edges sharp, not creating the relief, it will be difficult to fit your sheet metal part over there. So 6 times diameter 1 circles I placed and I made them all equal, and I created here one construction geometry. I select mirror, I select this all, and here mirror about. I copy them here. So I come here and link to thickness, cut. Yes, guys, this is good. This is how a professional part is drawn. Look at that, how nice it's looking like. Okay, the operation is now we go further. In this case, for example, you can open and make that change on part base instead of SE. This is now possible. We open a sketch on the corners, 2 time circle, and then give here diameter 1. Now we extrude cut. Now I can say draw all. That area will be cutted. I will create here a sketch. I will place here 2 circles. I will make them equal. And then maybe I can make them equal with those guys. Control is selected, but it's not allowed. Control is selected. And then I gave diameter 1. So this is good. And we say extrude cut. We will give here nice radiuses, which is radius 1. It's a little bit big, sorry. 0.5. All those edges selected. Even you can select this one. This is for repetition's sake. I will not go that much detail. We save it. Yes, we save it here. We save it here as well. And let's look what we have now. So a nice joint. What I would like to have now, adding my bolts. Let's open here. Let's edit this part and let's open here a sketch where we can place our bolt locations. Now I will make arbitrary choices. Here it's looking fine at the center, and then what I'm going to do at the center of this area, I'm going to create here a point as well. So these are simple sketches, nothing complicated. And after this operation, I will create here one more sketch, one more line, in fact, not sketch. I select everything. This will be my mirror path. So I determine my points. Something like this. We click OK. We go features. Plate is selected, and plate is the active part that we are working. Hole wizard. From here we select countersink, then active, standard, hex socket, the first one, and then size metric 3. Positions, I select my surface. I drop here 4x bolt head. So I select this one and Control is pressed. I select my point and I say midpoint. Select point, select line, say midpoint. Why we are not immediately dropping there, if you would ask? Because a point not defining a direction rotation per our part, our command wants first is flat surface. That's why I drop them firstly, and then now I am creating the first cut. So this is good. This is cutted. They are nicely here. So I will save again SE. Even now you can bring bolt and your nut even. So here I have a nut. Let's open them. Then nuts, thin nut. Create a part, which is 3. Metric 3 here you say. And now I go to bolts again. Then here design library, our design library. If it is not active in your program, you should go here, add-ins, and activate toolbox library here. Then you will be able to open this thing. It can take some time to activate it. Hex bolts and screws. Hexagon socket head screws here selected. The second one, create a part, metric 3 by 8. Before the tutorial I made it, that's why they are coming here ready. So on background if you look here, I have those files open. Insert components, first bolt. I just bring to my point and it is nicely defined. Insert components, hexagon tin nut. I put there and I will hide it for now and try to see what happened. Okay, so we have here some relations where I would like to remove one of them. The mates on our SE here, but it's always a good habit to go to part itself, mates and SE. So we are going to remove this mate and I will give 3mm gap. Surface selected. Sometimes I'm going fast, I realize. Mate selected, plate and top plate, and say hide. Guys, this is 3. Then what I would like to have, this edge parallel to this surface, and that will be created there, and I hide it. That's good now, and let's continue. Right click. This is the part that we would like to work, and preview is there, and I will just create here a line first. Let's do it on another different way. First to hide those two guys. I'm bothered with them now. We say again edit part. This is our edit part. This is our sketch. So we can use this one, which is fine. Here I draw 2 rectangle with center. It's fine. Control select, line select, point select, coincident, point select, control pressed, line select, coincident. So here we have a tree, metric tree. We give a clearance of half. This is good, 3.5, and this is 6. I don't know what happened here. We have having some height automatically defined. Oh, because of this guy. Let's remove it. Yes. Sometimes a lot of things matters when you work with this program. 2.5, which is a good operation, and I say okay. Features, extrude cut. Select this to object, length to thickness. That's fine. Because we will make some mirror, I just keep how it is. Now I will be working on the surface. I look normal to, click normal to, sketch already open. I select this edge and create a double line. Maybe you understand now why I am working in the same environment. Otherwise, you need to know all these details. Now we are depending on our model. It is visual, and it is always good to have it there. We say we give some relationship. Selected, edge selected, control pressed, relationship, line selected, point selected, coincidence. So what was it? Height is 3. This is 2.5. This length is 3.5 for a 0.5 mm clearance for our bolt, and this was 6. And everything looking perfect. We are almost done, guys. Extrude cut. Those two are cut. We can now save, and I would like to open this part individually and then a bit work there. Right plane selected, mirror, And the last two operation is selected two features and then say OK and then save and close. So we are almost done. It is looking very nice and it is a very professional example. I hope you find it as well. So they are here, guys. Our bolts are there. What we're gonna do, just select two of them, control pressed, and we are going to copy them here. So they have relationship in their own, but we miss something. Again, I select this one. This one have a coincidence here, which is not right. We select this one, move a bit down, press Alt, and come here. If you bring it to the position, it will be automatically mated. Again, Alt, and go down, and you have this relationship. So this is already here. I selected surface, and I will say Alt again. What happens? Let's see. Yes, I think it's saving. No, didn't have. Maybe it's a difficult point. Okay, then we select surface. Then we select the surface again, and we will align our nut to wall, and it is parallel and fine. So some mates are having difficulty seams. That's fine. I don't know now why it happened, but we will see. Bracket itself. No, mate. That's fine. We select all of our bolts and we go underlying components, mirror components, and select our right plane. This is the benefit of having right plane. If you work centered, your life always will be easy and you will not have any difficulty of aligning your parts. And this is the way of working, guys. In real life, we are working in this way. Otherwise, you cannot handle with the complexity of works always. Always it's good to have things clustered in a same area, same environment, and that will make your life much more easier. Maybe last professional detail. When you bend sheet metal parts, especially in the bending zones, you will see a surface increase. So this will not come flat. In this case, what we do as engineers, we select this two edge and say our program, cut them just 1 millimeter down. This is a bit much, not 1 millimeter writing, not linked to thickness, 1 millimeter. And then here, nice chamfers. One. Exactly how you see it. Yes. Close it. Yeah. Look how perfect it is now. Everything fully defined. Everything in a neat way we have been working. It is in the center of the SE model, and parts are having perfectly relationship. Nothing is floating. This is a real work example, and it's always appreciated. I hope you have learned something new from my video. If you like it, please hit the like button and see you in another video.